Good morning, Cappuccino. I had to start a new notebook. My other notebook filled up, so I imagine some of you might be having the same problem. And if you don't have a graph paper notebook, by all means, just use whatever you have. Don't worry about it. It's fine. So the last 2 days, you were doing an investigation on arithmetic and geometric sequences. And now we're going to formalize it, put it in our notes, and do a math space problem set on it. Next week, we're going to keep working with arithmetic and geometric sequences, but then we're going to be adding them together, which is called a series. Okay, so here is our formula packet. So we're actually just going over these formulas right here. So on Monday, this was the formula you were trying to discover in that investigation. And yesterday, this was the formula that you were trying to discover. So now we're going to talk about them. So first, we're going to talk about arithmetic sequences. Okay, so an arithmetic sequence is one where the numbers have a common difference between them. So you're just adding the same number over and over and over again to create the sequence of numbers. And we're just going to look at the formula right now. So to find the formula, okay, to find the nth term, so whatever term you're interested in, maybe it's the 5th, maybe it's the 10th, maybe it's the 200th, whatever, the nth term of an arithmetic function or sequence. We have the formula u sub n is equal to u sub 1, so 1, plus the term number minus 1 times d, which is the common difference. Okay, so this is the term you're looking for. This is the first term in the sequence. N is whichever term it is that you're looking for, say the 10th term, the 11th term, the 12th term, and d is how much you're adding each time to the previous term. Okay, this is directly related to a linear function. Okay, so this is related to a linear function. Y equals mx plus b. So does it look like y equals mx plus b? Not quite, but if we rearrange it a little bit, if I distribute the d, let's go ahead and rearrange it, and we'll make it look a little bit more like this. But this is really similar to a linear function, and that was what the investigation was trying to get you to figure out. So if I simplify, I have u sub n is equal to u sub 1, plus I'm going to distribute my d, so I'm going to get dn minus d. And then if I rearrange this, u sub n is equal to d times n plus, and I'm going to hook these two together, u sub 1 minus d. Okay, now this is the number we're looking for. This is how much it changes in between each number. This is which number are we looking for, plus, and then this is going to be a constant. So this is directly related to y equals mx plus b, where this is the y, this is my y, okay, the u sub n is my y, the d is my m, that's my slope, the common difference is my slope. The n is my x number, because I asked for, I want the 100th term, so that's my x. And then all of this is my y-intercept. Okay, so that's how it's all related. All right, so it's directly related to a linear function. So it's kind of like if you had a table. If you had a table, and I have this written down somewhere now. Where did I put it? Of course, I can't. Here we go. So it's kind of like I have a table. I wanted to graph a table, so I have a table like this. These are the ends, and these are my ends. and these are my u sub n's. Okay? So my x's are my n's, and these are my, so this is my n, and this is my u sub n. Okay, directly related. Alrighty, so let's do, what are some problems that we might be asked to do with this? So, for example, you might be given a sequence and asked to find a later term in the sequence. Okay, so for example, if I have 5, 9, 13, 17, etc., find the 10th term in the sequence. So two ways you can do this. You could just figure out, well, I'm adding 4 each time. I can see that. I'm adding 4 each time. So you could just keep adding 4 until you get to the 10th. But what if I asked for like the 50th or the 100th or the 1000th? That would be kind of a pain. You wouldn't want to just keep adding 4 each time. Okay, so it's good to use the formula. So we're going to use our formula. So change pen color. Why not? Just for fun. Okay, so I'm going to use my formula. U sub n is equal to u sub 1 plus d times, oops, I just switched it around, n minus 1. Okay, sorry, I just put the d in front, but same thing. All right, so I'm looking for the 10th sequence, number in the sequence. So my u sub n is going to be u sub 10. N is going to be 10. The first term is right here. That's my 5. And then my common difference. What's my common difference? I'm adding 4 each time. I'm adding 4. I'm adding 4. Okay, and if you're having a hard time figuring that out, all you have to do is take the second term and subtract the first term, and that gets you your common difference. Okay, that's our d. Okay, so d is 4, because that's how much I'm adding each time. N is 10. That's my n. So 10 minus 1. Okay, and then we just simplify it and we get it. Okay, so u sub 10 is equal to 5 plus 4 times 9 is 36. So u sub 10 is equal to 41. Okay, easy peasy, lemon squeezy. Okay, very similar to using a linear function. Right. Okay, so let's get a little harder then. What if I give you this? Next example. I have 0, and then u sub 2, u sub 3, u sub 4, and then 10, dot, dot, dot. And I want to find all those missing u's. Okay, so this is the second, third, and fourth term. I want to find those terms. Okay, so find each term. Okay, so I need to find these guys. All right, let's take our equation again, our formula. So I have u sub n is equal to u sub 1 plus d times n minus 1. I keep doing that. I like to put the d on the front. I don't know why, but I do. All right, so problem is here, I don't know what d is. So if I don't know what d is, how can I figure out what d is? I don't know what that is. So how could I find u sub 2 if I don't know what d is? Okay, so I need to find d. So to find d, I am going to use these two terms right here. Okay, so I need to find d. Find d. All right, so I know that I have this number here. I have 10. So I'm going to say that I know that u sub 4, sorry, 1, 2, 3, 4, 5. U sub 5 is 10. U sub 1 I know is 0. I don't know what the common difference is. But I do know that this is the 1, 2, 3, 4, 5. This is the fifth term. This is the fifth term right here. So I'm going to have 5 minus 1. So now I can solve this for d. 5 minus 1 is 4, so that's 4d. Subtract 0 from both sides. Divide both sides by 4. So d is equal to 10 over 4, which is 5 halves, or 2.5. Okay, now that I know what my common difference is, I can just use that to complete the sequence. Okay, there's other ways you could have done this, okay, but this is how I can do it just using the formula. So there's lots of ways to get yourself through these problems. This is just one way. Okay, so I have 0, and I know I've got to fill in these 3. So I know my common difference is 2.5, so I'm going to add 2.5. So 0 plus 2.5 is 2.5. Add another 2.5. 2.5 plus 2.5 is 5. Add another 2.5. I get 7.5. And then let's just test it, make sure it actually works. 7.5 plus 2.5 is 10. Bam! There it is. Okay, there are other ways that you could do this. You can think through it kind of logically, but this is how you can use the formula to solve a problem like this. Okay, so what's next? Geometric. So if we have a geometric sequence, that means each successive term is being multiplied by something. We're not adding, we're multiplying. So geometric sequence has this formula. Okay, I'm just going to write it down. So u sub n is equal to u sub 1 times r to the n minus 1. Okay, so it is directly related to an exponential function. Okay, so related to exponential functions. And the way that we write the equation for an exponential function is y equals ab to the x. Okay, so you can see what's going on here. It's like directly, it looks even more similar than the arithmetic one did. Okay, so here's our y, and here's our a, and then the r is our b, and n minus 1 is our x. Okay, so that's times, right? Okay, so it's an exponential function. So again, it's like having a table. It's like having a table. N is the x's, and y is the u sub n. Okay, but this time it's going to be an exponential function. Okay, r is the common ratio by which you multiply each term by. Okay, so let's write that down. What is r? R is the common ratio. Another way of saying that, or what you multiply each term by. Okay, let's do a couple of examples. So if I have 4, 12, 36, ... find the 10th term. All right, so writing down my formula, I'm going to have u sub n is equal to u sub 1 times r to the n minus 1. Okay, and remember, these formulas are in the packet. You can always refer to the packet. You don't have to have these memorized. Okay, so I am looking for the 10th term, so I'm looking for u sub, I'm looking for u sub 10. I know the first term is 4, and then I need to multiply that by r to the 10 minus 1. Okay, I got a problem here. I got two unknowns. Okay, so just like in the previous problem, the arithmetic problem, I needed to find d. So I can find d just by finding what's the difference between these. So that's what I need to do. What's the difference? But it's not difference because they're not being subtracted, or added, sorry. They're not being added with the d. They're being multiplied by something. So I know 4 times some number, r, is equal to 12. So 4 times some number r is equal to 12. So we just got to solve for r. So divide both sides by 4. And I get r is equal to 3. Okay, so there's a common ratio, that's r. So we're multiplying by r each time. So r is equal to 3. Now I can substitute that in. So u sub 10 is equal to 4 times 3, and 10 minus 1 is 9. And then I grab my handy-dandy calculator. I'm not going to do that by hand. 3 to the 9th? You got to be kidding. And I get u sub 10 is equal to 78,732. So you'll notice that these geometric sequences, just like exponential functions, because they are the same thing, goes up really fast. Okay, it changes really quickly. All right. Okay, so let's do an application of this. We are in the time of Corona, so let's do a Corona problem. All right, so our next example, there is an epidemic. In the U.S. Yes, there is. Okay, let's say on day 1, there were 2 cases of COVID-19. And by day 3, there were 50 cases. How many cases will there be on day 10? If we do nothing, right? If we don't shelter in place. How many cases will there be on day 10 if this pattern continues? Okay, so we need to bring some assumptions to this, which is that whenever you have an infection, it's going to be a geometric sequence. Okay, it's going to be an exponential geometric sequence. Okay, so we are going to be using our geometric formula for this. Okay, so we needed to bring that assumption to this problem. Epidemics are always exponential. Okay, so u sub n is equal to u sub 1 times r to the n minus 1. So we're looking for the 10th day. We're looking for u sub 10. We know on the first day there were 2 cases. We don't know what r is yet, but we do know we're looking for day 10, so that would be 10 minus 1. N is which day we're looking for, the term in the sequence. Okay, so how do we find r? So similar to what we did before, what is r? Okay, so we have the first day is 2, and then there's some second day, we don't know what it is, and the third day we know is 50. So we know if we take the first day and we times it by r, we'll get the second day, and then if we times that again by r, we'll get the third day. So I know that 2 times r again has to equal 50. So I have 2r squared is equal to 50. I can now solve this for r. So divide both sides by 2 to get the variable by itself, and then take the square root. So r is equal to 5. It doesn't make sense to take the negative one. I'm not going to multiply by negative 5. I'm not going to have negative cases. So just r is equal to 5. And then we can put that in. U sub 10 is equal to 2 times 5 to the 10 minus 1 is 9. And if we put that into our handy-dandy calculator, how many COVID-19 cases will there be on day 10 if we do nothing? 3,906,250. That is why we're sheltering in place. Okie dokie. So what you're going to be doing is you're going to be doing problems like this that are in math space, but a little bit of different notation in math space. Instead of using u sub n, okay, in math space, they use t sub n. They use t instead of u. So t sub n is the same as u sub n. And so therefore t sub 1 is the same thing as U sub 1. Otherwise, they use R, and same thing for arithmetic. U sub n would be T sub n. U sub 1 would be T sub 1. And I believe they still use D because it stands for common difference. Okay, common difference. How far apart are they? And then R, they use R because that's common ratio, and they use N. So the only difference is the U's. They use U sub n, they use T sub n for U sub n and T sub 1 for U sub 1. Okay, so that's a different notation you're going to see in math space. And real quick, number 20. Number 20 is tricky. Number 20 is tricky. So I would suggest use the hint. They have a really good hint. Use the hint. There's a really good hint on there. Otherwise, all the problems are pretty simple, pretty straightforward. That's why there's 20 of them. Okay, this is it for the week. I will not be posting any more assignments this week because it's just 3 assignments a week from here on out. So I will have office hours today at 10:30 and on Friday at 10:20. So hope to see you there if you have any questions. All right, take care. Good luck with math space number 98. Bye-bye.